Hi, I'm John, and this is my video about branching strategies. In this video, I'm going to be running through branching strategies with the Git version control system. I'm going to start by giving an introduction into branches and what they are. We're then going to be looking at why choosing a branching strategy for your team is essential, and then determining a branching strategy and looking at some of the questions we may ask ourselves when trying to choose a branching strategy that's suitable to our application or our team ways of working. And finally, we're going to be comparing some of the most common branching strategies and looking at the differences. We're also going to be looking at some real-world requirements from development teams and looking at which branching strategy would be suitable for those individual requirements. So I'm going to start by giving an introduction into branches. So branches are independent lines of development that don't affect the original line. So every Git repository has typically a main or a master branch. And if we visualize this as a tree, the main or master branch is the trunk of the tree. And this is where our production-ready, deployable, tested code is stored. We can then create branches from our trunk, and these are called branches in Git. And this is where we work on features or bug fixes or new lines of development. And branches ultimately are essential to collaborative software development. So when we've got those separate branches, if I'm working on a feature, I can have a colleague working on a different feature in a different branch. There could be another colleague again working on a bug fix. And the work that we're doing and the code base we're working on aren't going to cross over each other until we get to, or when we're ready to merge it back into the main branch, which we can have a lot of processes around to mitigate the risks associated. So ultimately, it allows teams of developers to work on independent lines of code without affecting each other and without affecting production until it's ready to. So why are branching strategies essential? Well, they dictate how branches are created, used, and integrated during the life cycle. So they'll give the example of the main branch and then, the trunk of the tree and then the branches that come off that tree. There's actually many different branching strategies that determine when or how we create branches, what are the purposes of branches for features, bug fixes, or releases of our application. So the branching strategy and the way we choose to work with branches is going to have a massive implication for the way that we work and the speed that we can work for our application and build our application and make changes and the processes around it. So that is why branching strategy is essential. It ensures smooth development, collaboration, and release process in accordance with the ways that we want to work and the way that our application needs to work. And the advantages are accommodating procedures for code integration, like code reviews, automated testing, work items, build validation. Branching strategy will have big implications for how those processes will work and how efficiently we can do it. Working on separate features and bug fixes, as I mentioned, without crossover with other developers or production. And also easier rollback to previous stable states. So we can have a well-defined process for rolling back if we need to when we've got a specific branching strategy and a tested rollback mechanism that we understand. When we're determining a branching strategy, what questions might we ask ourselves? Well, we've got project nature and size. Is the project small, medium, large, short-term, or long-term? So DevOps and DevOps methodologies, one of the key principles is to be doing rapid integrations and not having long-living branches, having short-living branches, integrating our code ideally frequently, several times per day. And the branching strategy we choose is supportive of that, depending on which one we choose. How many developers are going to be working concurrently and potentially even separate teams? So we could have one team of developers that could be working in separate branches, But if we've got different teams that are also working on different parts of the application, that might influence our branching strategy to ensure we've got proper process and we can mitigate merge conflicts and things like that as well. How frequently do you release? Do you plan to maintain multiple versions concurrently? So this can again influence our branching strategy. If we need, if we work on release numbers and we need to maintain multiple code bases, then we may look at a release branching strategy, which I'm going to look at shortly. Do you practice CI/CD? So a lot of the branching strategies are more supportive of CI/CD processes and frequent integrations of code several times per day. And what are the team's familiarity with different branching strategies? So if we've been working one way for a long time and then we're moving to a new branching strategy, this is going to require the team to rescale or potentially even change their culture and their way of working entirely. So we need to take that into consideration as well. Okay, so let's dive into some common branching strategies. The first branching strategy is trunk-based development. So if we go back to the analogy of having a tree, we have the main trunk and then we have branches coming from the trunk. Trunk-based development refers to making commits directly to the main branch. So developers push directly. Short-lived branches are used for larger features still or more complex changes. And this is the least complex of all of the branching strategies in terms of the way that our branches work, because a lot of the changes we'll make directly to the main branch. There's no creating a branch or pull request. We still might have automated mechanisms, and we should have automated mechanisms around what happens to the code before it gets to production. But in terms of branches, this is the simplest branching strategy in terms of complexity. Strongly associated with continuous deployment and encourages frequent deployment. So in its nature, by committing directly to main, we're encouraging rapid release or integrations, deployments. So this is very supportive of a mature DevOps culture around frequently integrating our code. It does require high team maturity, robust automation, high code coverage for unit tests, pro-efficiency in writing unit tests, and a good culture, good discipline around writing good comprehensive unit tests for the changes that we're making, because they're going to be key. If we're modifying the production code in the main branch directly, we're really relying on robust automation and testing to mitigate issues that could happen and get quickly applied to production. Reliable rollback mechanisms as well. Another area to consider with trunk-based development is feature flags. So we don't want users to be receiving incomplete features or having visibility of incomplete features. So we'll be dependent on feature flags for controlling what the user sees, ensuring that they're not going to see incomplete features. And the use cases for TBD, trunk-based development, is continuous integration, rapid software iterations, and agile and scrum methodologies. So this is a visual representation of a trunk-based development. We've got the main branch. The developer may commit directly to main. We then have short-lived branches here. So we do still use short-lived branches, as I mentioned, for the more complex or bigger changes. This then gets merged into main again. And then we've got another short-lived branch. So it's a combination of merging or committing directly to main and creating short-lived branches. The next branching strategy is feature branching. And with feature branching, we create a new branch for every feature or bug fix. Changes are merged into the main branch when we're ready and we're finished with our code changes. And they're merged with using a pull request into the main branch. The downside to feature branching is it can lead to long-lived branches that can later cause merge conflicts. And this is against DevOps and agile methodologies in continuous integration and continuous deployment. When we're having long-lived branches, the longer the life of the branch, the more chance of merge conflicts with other developer branches, and the more risk generally that there is. Use cases are parallel development of multiple features when needing to isolate changes for a specific feature or bug fix, and large teams with multiple ongoing projects. So this is an illustration again now of the feature branching. So we've got the main branch. We then create feature branches that get merged back into main when we're ready. And then we create more feature branches and the process continues. So the next branching strategy is GitHub flow, and this is very similar to the trunk-based development and feature branching, in that we do also create feature branches with the GitHub flow branching strategy. But GitHub flow encourages a more streamlined workflow, and there's a bigger emphasis on frequent integrations and continuous delivery. Use cases for this are web-based projects, GitHub-centric projects, continuous delivery, and continuous deployment. So trunk-based development, GitHub flow, and feature branching, very similar in branches. Trunk-based development, we're committing directly to main some of the time. Feature branching and GitHub flow are very similar, but GitHub flow has a bigger emphasis on frequent integrations and continuous delivery. So this is another diagram again very similar. We have the main branch, we create branches where we do our features, we merge into main, and then do the same process again. So since trunk-based development and feature branching and GitHub flow are very similar, I just wanted to do a quick comparison and just point out the unique characteristics. So in terms of basic workflow, trunk-based development where we're committing directly to main, direct commits to trunk, and very short-lived branches. So big emphasis on continuously integrating our code, and this branching strategy is very encouraging and supportive of frequent integrations. GitHub flow, branch for every change, followed immediately by PR, review, test, merge, and deployment. Whereas feature branching, branch for each feature or bug fix, merge after review and testing, but doesn't dictate immediate deployment. So mature teams where we have DevOps methodologies and agile methodologies, big emphasis on integration and deployment and continuous deployment. Feature branching doesn't dictate the immediate deployment side of that. Then deployment, trunk-based development, frequent deployments with optional feature toggling. GitHub flow, always continuous deployment after every merge. Feature branching, flexible, can batch features for releases or deploy individually. Environment considerations, for trunk-based development, we've got rapid integration and testing. Environment specifics are flexible. GitHub flow, typical use of a staged environment before production. And with feature branching, multiple potential environments, dev, staging, prod, without strict flow between them. And then hotfixes, direct commits for urgency and short-lived branches for the trunk-based development. GitHub flow, treated exactly like feature changes with immediate deployment. And with feature branching, separate branches similar to features with flexible deployment timing. And finally, we have tooling and platform, robust CI/CD tooling essential for trunk-based development, making those commits directly to main, heavily relying on robust automation. GitHub flow, optimized for GitHub's features, especially pull requests. And feature branching, VSC, version control system agnostic, emphasizes pull requests for collaboration. So this is the comparison between TBD, feature branching and GitHub flow. Again, very similar, but they do have unique characteristics. And a common choice would be typically trunk-based development or GitHub flow. So I'm going to get now into three more branching strategies, and these are more abstract branching strategies. Two of them are more traditional, but still applicable today. There's still definitely use cases for these branching strategies. But these are the three: TBD, feature branching, and GitHub flow are considered to be the most agile, modern approaches. So the next branching strategy is forking branching strategy, and this is a bit different from the other ones because it's less about an internal development team, and in a lot of cases more about open source projects or projects with external contributions. So it's equivalent to feature branching and similar in the way that we work on separate code, a different line of code, but instead we create a fork which is effectively a clone of the repository rather than a branch from the repository. And this is required when contributing, but you only have read access or limited permissions to the repository. So if there's an open source repository you come across on GitHub and you've been working with the code there, publicly available repository, and then you decide that that repo could benefit from a change, so you want to make a contribution to that open source repository, you would use, in most cases, the forking strategy. You would create a fork, make your changes, and then create a pull request to whoever owns the repository. And this is mostly applicable for open source repository. This is what it's most common for. We then have release branching, and the release branching strategy is all around applications where we need to maintain multiple versions of an application and therefore multiple code bases. So as with most of the other branching strategies, we've got one code base really that's been through many iterations over time, but we're only maintaining one code base and one ongoing version. With release branching, if we've got an application that we provide to customers and the specific versions, some customers may still be on one of those older versions and we need to apply hotfixes or updates to one of those older versions. This is a good use case for release branching. So it's one branch per release, possibly worked on by separate teams. Hotfix branches created directly from main. So this is the one thing we do directly from main when we need to do urgent hotfixes for a critical issue. We do that against main. Release branches are long-living, typically weeks or months. So very different to some of the other branching strategies we've just looked at. Less of a focus on frequent changes. This is more about doing a monthly or a quarterly release. Generally not recommended unless you require the support for separate code bases, software versions, that must be maintained on an ongoing basis. Merge conflicts are often expected with this release branching strategy as well, when we've got separate developers and potentially even separate teams working on different versions or different parts of the code, the application. The longer these branches live on, the higher chance there is of differences or conflicts when we come to merge our changes back. And these come to be expected with the release branching strategy because we're not doing frequent integrations several times per day as we would with some of the other branching strategies. Typical use cases for this are mature projects that require stable releases, as I mentioned, projects that need to manage multiple versions in parallel, when hotfixes are common and should be applied without touching the main line. So this is an illustration of the branching strategy. We've got in the corner here the main stable release, and this is 1.0. We create a branch and start working on 1.1. We can do a bug fix or a feature from 1.1. As the current version, that gets merged back into main. Main is always the latest stable release that we've got. But as we merge that back into main up here, 1.1 continues to exist. And that is going to be a code base that's continuously worked on over time as we have more bug fixes and features potentially we want to add to that specific version. So then we go from main and we go to the next version, 1.2. We do bug fixes for that, features changes for that, merge back into main. 1.2 again continues to live on. So as we keep moving through versions, these branches, which become old branches, still exist because we've got customers out there that are still using that version and are still going to need bug fixes and changes to that version. So you can see how this can become quite complicated when we're managing multiple code bases. And it's very different from some of the other branching strategies we've looked at. So the final branching strategy is the Git flow branching strategy, and with this we have a main branch that contains the stable code. Again, from this main branch we create a develop branch, and this serves as an integration branch. We do a lot of our operations and integrations into this branch before production. We have features coming from the develop branch. Release branches are then used to prepare for production release. So we're working on those feature branches. We integrate into the development branch. When we're ready to merge into the main branch, we first create a release branch, perform any minor bug fixes or metadata changes, and then it's ready for production. We can merge it back into main. We do, though, also have hotfix branches, and these again could potentially come directly from main, so skip out the develop branch. And the reason for this is typically hotfixes are going to be urgent. If we've got a critical issue in production, we need to get it through as quickly as we can. We don't necessarily want to go through the develop branch or disrupt what's going on in there and the changes that are being integrated at that time. So in that case, we'll go directly from main for hotfixes. Those changes in the hotfix branch that we create would get merged into main, most importantly, but also the develop branch as well. It's typically considered overcomplicated. It can be very complicated, the Git flow branching strategy. That doesn't mean to say that you shouldn't use it. There's use cases for this branching strategy and scenarios where you might use it, but it can be complicated, and that's the downside of this. Use cases are web-based projects, GitHub-centric projects, and continuous delivery and continuous deployment. So another illustration, and this is for the Git flow branch strategy that we just went through, and we've got a main, which is a later stable version. We have a develop branch. We work on a feature branch from the develop branch, and then we create a release branch from the develop branch, and then we merge back into main. It's not on this diagram, but we would also have hotfixes from main when required, as I mentioned. Okay, so now I just want to do one quick final comparison between all of the branching strategies. There's a lot of information here, so I'm not going to go through all of it as I'll be here for quite a while, but I just want to point out some of the key differences. So basic idea of trunk-based development: developers work in short-lived branches and directly from the trunk. Feature branching: every new feature or fix is developed in a separate branch. GitHub flow, very similar, but it's a simplified workflow with master branch and feature branches deployed from master. Forking strategy, which is for the open source projects typically. Developers fork from the main repository. And then release branching, branches created for potential fixes, allowing for fixes without affecting the main line. Finally, I'll run through some of the cons to call out. So with trunk-based development, we have that risk of breaking the main line. We're making commits directly to main. There's an inherent risk for that, but that can be mitigated against using that robust testing practices. For the feature branching strategy, merge conflicts can grow over time, integration issues if branches live too long. GitHub flow, similar to feature branching, not ideal for complex projects with multiple environments. That's one of the disadvantages of that. Then release branching, overhead in managing multiple release branches and can drift from the main line. So that was one of the biggest downsides of release branching, just the large complexity and the separate releases. Merge conflicts are almost inevitable. Okay, so in the final part of this presentation, I just want to look at some real-world requirements that development teams might have, and then look at some of the most suitable branching strategies that may meet those requirements. So just to give some real-world examples to help you understand when we would use some of these branching strategies. So first of all, the requirement is a small team looking for simplicity. In this case, we would choose between likely the GitHub flow or the trunk-based development. GitHub flow offering linear and uncomplicated workflow, ideal for smaller teams to avoid management overhead. Trunk-based development promotes direct commits and quick merges, ensuring a streamlined workflow without branching complexities. So less complexity, good for small team looking for simplicity. I suppose the trunk-based development is complex in a different sense because we need robust automation, and that's going to take a lot of discipline and work to maintain. But in terms of branching, trunk-based development is the simplest. External contributors without direct repo access, forking strategy for this, as I mentioned, with the example of GitHub open source projects. And then large open source projects with numerous collaborators, again, forking and Git flow. Forking allows for decentralized contributions. Git flow adds the benefit of simplified workflow with continuous feedback loops, making it easier to manage and review contributions. And then regular product releases. This would be the release branching and the Git flow branching strategies. Release branching ensuring that code related to specific releases is isolated, making version management easier. With the Git flow, we're providing a comprehensive structure, distinguishing features, releases, and hotfixes, ensuring organized and controlled releases. So this is consistent with what we want when we've got regular product version releases and the complexity of maintaining multiple versions. So then in the area of complexity, in the area of delivery, we've got teams focusing on rapid iterations and feedback, and trunk-based development and GitHub flow are definitely the most suitable branching strategy for these. Trunk-based development emphasizes frequent integrations into the mainline, very supportive of rapid iterations and feedback. GitHub flow, slightly more barriers, of course, because we're using feature branches more often, but it still advocates for short-lived branches, regular deployments, and a cycle of continuous feedback and improvement. Then we have a requirement being a junior team with limited branching experience. GitHub flow is a simple branching strategy that can help teams in that scenario. Reduces the learning curve, so for teams new to branching, its linear approach to branch, commit, and merge is intuitive and minimizes complexities. Next requirement, regular product releases, release branching, and Git flow ensures that code is isolated for specific releases with a release branching strategy. I think this is actually a duplicate from the previous slide, but ultimately Git flow, comprehensive structure and distinguishing between features, releases, and hotfixes. And then maintaining legacy versions, release branching, and Git flow. Then we have, in the area of delivery, teams that require separate environments for development, testing, and production. Most suitable strategies for these would be Git flow, GitHub flow, and feature branching. So Git flow ensures separate branches for each environment, promoting stability and phased deployments. Though that has a lot of complexity with Git flow, it does meet that requirement technically. GitHub flow emphasizes continuous integration and deployment. Feature branching provides isolated environments for individual features or changes, reducing integration conflicts. Then the next one is if your team has an existing pain point, frequent code-based disruptions due to experimental features. And this would be trunk-based development, feature branching, and Git flow. Trunk-based development, allowing short-lived branches for quick reintegration and minimizing disruptions, feature branching, isolating experimental features, protecting the main code base, and then Git flow structure further ensures experimental features are developed in distinct branches. Requirement for stable mainline while accommodating hotfixes. Git flow for that. Git flow has dedicated hotfix branches derived from main production branch, ensuring that urgent fixes can be applied quickly. And then this is the last slide, and I think these are actually a duplicate of what was on the previous slide, but ultimately large open source projects with numerous collaborators and external contributors without direct repo access, a mixture of forking and the GitHub flow, branching strategies, with the forking branch strategy especially. If it's a publicly available repository, there's no permissions required over the repository to create a fork and modify that code base. So that concludes my presentation on Git branching strategies and some of the common branching strategies we might use in some of the different scenarios and some of the real-world requirements. Ultimately, trunk-based development, feature branching, and the GitHub flow branching strategies are the simplest branching strategies for specific use cases. Release branching, Git flow, and the forking strategy may be suitable. Thank you for watching.